Greetings, fellow macros. Today, we're going to be going over the substitution rule. Here is the problem. Evaluate the following integrals. In part A, the integral from 0 to 2 of dx divided by x plus 3 to the third. In part B, the integral from 0 to 4 of x divided by x squared plus 1 dx. And in part C, the integral from 0 to pi halves of sine to the fourth of x times cosine of x dx. Now pause this video, take a few minutes, and solve this problem. Welcome back. Hopefully you were able to solve this problem. Now let's work on it together. So in part A, what will be our u? Well, our u in part A will be equal to x plus 3. Therefore, our du will be equal to the derivative of u, which will be 1, or dx. So now, also too, since we now have definite integrals, we now need to change our boundaries. So we need to plug in 0 and 2 into u so we can solve our integral. So when u is equal to 0 plus, or when, let's do this. When x is equal to 0, u is equal to 0 plus 3, which is equal to 3. When x is equal to 2, our upper boundary, u is going to be equal to 2 plus 3, which is equal to 5. So now we have our new boundaries and our u and du. We can now solve our problem. So in part A, our integral, our definite integral. So now in part A, our integral will become the integral from 3 to 5 of u to the negative third du. So all I did was take our denominator, which was u to the third, and bring it to our numerator, so it becomes u to the negative third. And since we have dx, it's du. So now if we take our integral of this, it will become the integral. It will become u to the negative 2 divided by negative 2. So let's do this. This is equal to negative u to the negative 2 divided by 2 of 3 to 5. So now we need to plug in our 5 and 3 into our u. So this will become, this is equal to negative 1/2 times 5 to the negative 2 minus 3 to the negative 2. And if we plug this into a calculator, this will be equal to 8 divided by 225. And that will be our solution for our definite integral for part A. So the integral of 0 to 2 dx divided by x plus 3 to the third is equal to 8 divided by 225. Now in part B, we need to find our integral for 0 to 4 of x divided by x squared plus 1 dx. So what will be our u for part B? U will be equal to x squared plus 1. If we take a derivative of u, our du will be equal to 2x dx. Well, we have a constant, so we can take out a constant. So therefore, we will get 1/2 du is going to be equal to x dx. So, and when x is equal to, let's find our boundaries, our new boundaries. So when x is equal to 0, this means that u will be equal to 0 squared plus 1, which is equal to 1. And when x is equal to 4, u is going to be equal to 4 squared plus 1, which is equal to 17. So now that we have all the information we need, let's solve this problem. So our integral becomes the integral from 1 to 17. Okay, our integral becomes 1/2. I'm going to take out a constant. 1/2 integral 1 to 17 of x dx, which is du. So then we get u. So it becomes u to the negative 1 du. So since our denominator is our u, I'm bringing u into our numerator, so it becomes u to the negative 1. And what is the integral of u to the negative 1 du? Well, this becomes 1/2 natural log of u from 1 to 17. And now we just plug this in. So we get 1/2 natural log of 17 minus the natural log of 1. And this will be our answer for part B. The definite integral of 0 to 4 x divided by x squared plus 1 dx is equal to 1/2 the natural log of 17 minus the natural log of 1. Now for part C, for part C, we have the integral from 0 to pi halves of sine to the 4th of x times cosine of x dx. What will be our u for part C? Our u will be equal to sine of x. So if we take a derivative of that, our du is going to be equal to cosine of x dx. So if we plug in, and when x, wait a second, and when x is equal to 0, u is equal to sine of 0, which is equal to 0. And when x is equal to pi halves, u is equal to sine of pi halves, which is equal to 1. So now we found our new boundaries and our u and du. We can now solve this problem. So our integral becomes, this is going to be equal to the integral from 0 to 1 of u to the 4th du. If we take the integral of that, this is going to be equal to u to the 5th divided by 5 from 0 to 1. 0 is going to give us 0, so this just becomes 1 divided by 5. This becomes 1/5. That will be our answer for part C. And so the definite integral of 0 to pi halves of sine to the 4th of x times cosine of x dx is equal to 1/5. I hope this video helped. If it did, please consider subscribing and liking this video. Thank you.